So, you're here to learn about ants. Specifically, Solenopsis invicta, also known as the red imported fire ant. After taking over, making their home in the southeastern United States, these ants have some interesting behavior during floods, forming rafts made up of thousands of individuals that allow the colony to survive while it floats towards its new destination. As you can imagine, floating in volatile waters without food for days on end is pretty stressful for the ants, taking up an average of 43% more energy than they would on land. Water is hardly ever completely still in nature, especially not during a flood. Despite this, pretty much no one's looked at the energy consumption of ant rafts in relation to water volatility. And who better to fill in that gap than us? Over the past 3 months, we investigated whether stronger water turbulence would increase the amount of energy consumed by rafting ants. So how do you simulate a flood for ants? Simple. You build an ant vortex. We set up a test apparatus using a 2-liter media storage container filled halfway with water and a carbon dioxide gas sensor. We then gently insert some ants into the container, where they immediately start clumping together, and just let them sit there for 5 minutes or so to acclimate to the water. And then we spin them. Ant rafts made of 5, 2.5, or 1 gram of ants were spun at low, medium, and high turbulence, coming out a total of 9 different trials. The gas sensor then recorded the concentration of carbon dioxide in the container over time, which we use as a proxy for metabolic consumption. 20 Excel spreadsheets and a convenient equation later, we converted carbon dioxide output to metabolic rate, expressed in watts. We were able to calculate the metabolic rate of each group of ants at different intensities of water turbulence. The larger 2.5 and 5 gram rafts actually saw their metabolic rate decrease when introduced to turbulence. At first, this appears consistent with past research where energy efficiency is inversely correlated with size, although the same paper also found that the size effect only seemed to apply to individuals, not groups of fire ants. The unexpected metabolic efficiency of larger ant rafts in volatile water could be due to a number of reasons, the most likely being the deformation of rafts while they're spinning. During our trials, we noticed that the shape of the ant rafts would often contract towards the center with increasing turbulence, possibly due to the forces behind the vortex itself. Although the results are approximations at best, we believe that the reduction in surface area might be responsible for the decline in energy consumption that we see in the larger rafts.